So sometimes when we're trying to solve a quadratic function where we're trying to find the zeros, we're trying to find the x-intercepts. In fact, let's see here, pen time. So when the quadratic function is set to 0 and we're trying to find the x-intercepts, we usually like to factor first, but sometimes that's not possible. So when I first look at this, I think, okay, maybe let me factor the 9 out. So then I have x squared plus 14 over 9 minus 1 equals 0. And then I would try to find factors of -1. So I'm trying to figure out what times what gives me -1. The only ones I think of off the top of my head are +1 and -1. And then do those factors add up to the positive 14 over 9? No, they don't. So then I realize now that I'm going to have to get into the decimal realm. I'm going to have to find numbers that are decimals that multiply to -1 and add up to the fraction of 19 over 4, or sorry, 14 over 9. Um, that's a lot. So I wouldn't go the factoring route here, but there is a way. There is a way to figure out what are the x-intercepts without factoring. Okay, so a long time ago, mathematicians found out how to solve for x from the standard form of y equals a x squared plus bx plus c. They figured out literally how do you solve for x. So there's a long, intricate way to solve for x here. Okay. The crazy long steps look something like this. And you're probably like, what the heck? That's too much. Yeah. You can look that up on your own time a different day. I'm just going to show you the formula for how to solve for x. And you can do it. You can do it. So first and foremost, when you're thinking of the quadratic function, you need it in standard form. So what you see on the screen in red, that's the standard form of a quadratic function. And so you need to know specifically what the A is, what the B is, and what the C is. The A is whatever's being multiplied by the x squared term. The B is whatever's being multiplied by the x term. And the C is the constant, the number that's by itself. So in the function that we have at the top of the screen, um, A is 9, B is 14, and C is -9. After the mathematicians spent a little while figuring out what x equals, this is what they found. They found that x equals -b plus or minus the square root of b squared minus 4ac over 2a. Okay, just take a second to look at it. This is a lot. But this is the formula and it works every time. As long as the function is in standard form, we know what A is, we know what B is, we know what C is. We identify it. So let's try it out for this function. So x equals -b. So we already figured out that our b is 14. The multiplier of x is 14. So instead of putting b, I'm going to put 14. But I'm putting -14 because it calls for the opposite sign. So -14 plus or minus, because it's going to be two answers most likely, the square root of the b squared. So 14 is b. So 14 squared minus 4 times a and times c. So our a is 9 and our c is -9. So that's what I'm putting in the parentheses. A, oops, and C. Okay, No, it's a little ugly. But those are a positive 9 and a negative 9. And then all divided by 2 times a. And in this case, a is 9. Okay, now I simplified. So let's see here. So we have x equals, actually, let me change color. So negative 14 plus or minus the square root. Okay, let's see. So 14 squared, I believe that's 196. So 14 times 14, 196 minus 4 times 9 times, so negative 4 times positive 9 times negative 9. So I'm just using a calculator right now. So negative 4 times positive 9 times negative 9. So I get positive 324. And then over 2 times 9, which is 18. Okay. We're getting somewhere. It's getting smaller. So now I need to do my square root before I do anything else. All right. So 196 plus 324. 520. So it's going to be negative 14 plus or minus square root of 520 divided by 18. All right, let's figure this out. What's the square root of 520? So the square root of 520, it's going to be a decimal. And it's a non-repeating pattern. It's a irrational number. The decimal goes on forever and ever and ever and ever and ever. So I got 22.80350850, so forth and so on, and so forth and so on. Obviously, I'm not going to write all those digits. I'm going to round 4 digits after the decimal. So let me actually erase some of this up here. Okay. So now that we know the square root of the approximation of the square root of 520, I'm going to say negative 14 plus or minus 22.8035 divided by 18. Okay. See, it's already getting smaller for those of you that are looking at this like, oh my gosh, that's so much. But it's getting there. It's getting there. Okay. So now, because I have this plus minus, what this is saying is there's 2 possibilities for the answers. And so I'm going to go with one possibility on one side and the other possibility on the other side. So possibility number 1 and possibility number 2. All right. So first of all, possibility number 1 is negative 14 plus 8035 over 18. And the other possibility is negative 14 minus 22.8035 over 18. Okay, here we go. And I'm just going to use my calculator. So negative 14 plus. So then I get 0.8035 divided by 18, which equals 0.489. And then it goes 0.833333, but I'm just going to round to those digits there. Okay, and now for the second option, so it was negative 14 minus, okay, so let me do that in the calculator. So that's negative 36.8035 over 18. So divided by 18, which equals negative 2.0446. Okay, I'm done. Here's my answers. Now, what do you notice about these answers? Well, they match. I already found the answers earlier. I already graphed this just to see what would happen. And these answers match. Negative 2.045, if I were to round this, that's what it will be. And then 0.489. I mean, yeah, we did it. We found the decimal approximations of the answers. We would have never figured that out by factoring. Okay, maybe there's someone in this world that would have, sure, but I didn't want to use that much brain power. So this is the shortcut way, even though it doesn't feel short. But this is the shortcut way to figuring out what the x-intercepts are, the zeros are, when it's not so easy to factor. Hope this helps.